This is fourth lecture of this short-term course, and this lecture deals with the substitution reaction of the type SN-NGP. NGP means neighboring group participation. That means when a substitution reaction takes place at a carbon center, a neighboring group interferes during the reaction process. This is it, SN-NGP reaction. The definition you can look it on the screen. The direct interaction of the reaction center with a lone pair of electrons of an atom or with the electrons of a sigma or pi bond contained within the parent molecule but not conjugated with the reaction center. So the key point to note here, the group or the atom which interfere with the reaction center should not be in conjugation with the reaction center. This is the important point to note here. The mechanism we can explain in this slide. In the first step, the neighboring group, that is Z, act as a nucleophile and pushes the leaving group, that is X, but still remain attached to the molecule. That means the X leaves but not the Z. Z will remain in the molecule. In the second step, the external nucleophile, that is denoted as Y, red color, displaces the neighboring group from the reaction center, and this is how the neighboring group participation reaction mechanism occurs. That means here Z is the neighboring group which interferes during the reaction process, and Y is the ultimate incoming group, that is nucleophile. In the mechanism, Z acted as nucleophile as I have already told, and leaving group releases at the first step. If there is no nucleophile, that is Z is equal to hydrogen. For example, you consider Z as hydrogen. Then what will happen? Then hydrogen has no lone pair of electron. It has no capability to donate electron, and thus it cannot interfere with the reaction center, that is in the substitution process of Cl bond. Thus the reaction rate will be very low in comparison with the first one. That means we can say when there is neighboring group participation occurring, the reaction will be very fast, else the reaction will go very slowly. So we can also see the statement here, Z when having electron pair, that is donor, helps in the removal process of leaving group, and we have seen in the SN1 type of process, the leaving group detaching process is the rate determining step. As the rate determining step is facilitated by the neighboring group, the reaction rate increases drastically. In this slide, we will talk about the groups which are expected to display neighboring group participation process. So as I have already mentioned, the conditions to behave like a neighboring group, there are two conditions. The first condition is lone pair of electron, and the second condition is pi electron. It is important to note the groups that are having electron richness, that means they have extra electron to give, that means lone pair of electron or pi electron. We know that pi electrons are easily polarizable, so these electrons can be donated easily. Therefore these type of groups can act as neighboring group in SN1 process. For example, here we have written, here I am showing one example with thiol, alkyl thiol. So thiol has sulfur and it has lone pair of electron. When the Cl bond takes place, the sulfur atom, as it is having one lone pair of electron, can be donated and act as neighboring group and facilitate the substitution reaction. In the next, you can see that this is dialkyl amine group, where nitrogen has lone pair of electron and also it can act as neighboring group. Next is O minus. O minus, it has rich electron. Bromine has 3 lone pair of electron, and one of them can be donated and it can behave like a neighboring group. Here carbon double bond is also there, and an aryl group is also there, that is phenyl group, and both of them has pi electron cloud, which is easily polarizable and can be donated during the substitution process. The effect of neighboring group participation is anchimeric assistance. If the neighboring group participation results in an abrupt increase in the rate of reaction, then the phenomena is known as anchimeric effect or anchimeric assistance. This is very important to note. One of the example, here I am showing two examples. On the reaction with water, both hexyl chloride and mustard gas. You note the structure of hexyl chloride and mustard gas. Both of the substrate, while reacting with water, shows an anchimeric effect. No, I'm sorry. On the reaction with water, both hexyl chloride and mustard gas give their corresponding alcohol. That means CCl bond is substituted by OH group. As the mustard gas has sulfur atom embedded, which has lone pair of electron, it will show anchimeric effect. That is neighboring group participation. Therefore, the mustard gas will undergo substitution reaction much faster than the hexyl chloride because it has no group to participate to facilitate in the substitution process. Therefore, the rate of mustard gas towards reacting with water is found to be 700 times faster than that of hexyl chloride.